In this lesson, we're going to work on dividing polynomial functions. So by the end of this lesson, you should be able to do that. We're also going to be using the following words a lot: dividend, quotient, divisor, and remainder. So by the end of this lesson, you should have a good understanding of what those are. So the reason why we're doing this is because we've been working on polynomial functions, but we can't graph them unless we have their zeros. So we can determine its end behavior. We know which quadrants it might start in and end in based on its leading coefficient and its degree. But unless it's factored, we can't actually do a somewhat accurate graph because we won't have the zeros. So we're working towards being able to factor long polynomials of a degree that's greater than 2. So to get us warm up, we're going to go way back to elementary school when we used to divide using long division. So that's actually the technique we're going to use when we're dividing polynomials. So let's start by dividing 107 by 4. So if you remember, you've got to set up your division sign here. Okay, underneath the division sign, we have our dividend. So this is our big number that we're going to divide. Then on the left, we have our divisor, that's 4, and our quotient, so our result, is going to be right on top here. So if you remember, the first question that we ask ourselves is how many times does 4 go into 1? And if that doesn't work, we go to 10. So how many times does 4 go into 10? And we know the answer to that is 2 times. So 2, and then we're going to go times 4 is equal to 8. We're going to put that right underneath the 10, and we're going to subtract. So now we have 10 minus 8, which just works out to 2. And then we're going to carry down the next number, which is the 7. So now we ask ourselves, how many times does 4 go into 27? We know it goes in 6 times, so we're going to put a 6 here. And then we're going to multiply. So 6 times 4 is 24. And then subtract, and we've got a 3 left over. So if we label these words, this guy here is called the dividend. So that's the thing that we're going to divide. The thing that divides into the dividend, that's the divisor. That one's sort of a logical word. And then at the top, we know that when two numbers are divided, the end result is called the quotient. So there's our quotient. And then at the bottom here, we don't have a remainder of 0, we have a remainder of 3. So this is called the remainder. So in summary, our final answer is we were asked to find what's the quotient of 107 and 4. And we know that that answer is just 26 and remainder 3. Another way to write that is that 107 divided by 4 is equal to 26 and 3/4. So if we were to actually put this in the calculator, 104 divided by 4, we should get 26.75. So in general, when we're dividing numbers or polynomials, these statements are going to be true. This is a representation of the relationship between the quotient, the dividend, the remainder, and the divisor. So we know that the dividend, which is in this case 107, has to be equal to these two numbers plus the remainder. And that's what this is saying. This is saying the dividend is equal to the quotient times the divisor plus the remainder. So if we were just going to use the example above, our dividend is 107. And that has to be equal to our quotient, which is 26, times our divisor, which is 4, and then add the remainder. And we can triple check to make sure that that's true, and it will hold true. Another way to represent this is if we take this and we divide it by the divisor. So we divide this guy by the divisor, this guy by the divisor, and this guy by the divisor. We're going to get this property here, which is the original question, which is the dividend divided by the divisor. So in this case, 107 divided by 4 is going to equal the quotient, 26, that's our answer, plus the remainder over the divisor, which is what we have represented right here. So just to summarize, our dividend was 107, and dividing it by 4, that was the question, is going to equal 26 with a remainder of 3, which works out to 3 over the divisor, which is 4. So those are two equivalent ways of representing the relationship between all of those 4 things: dividend, quotient, divisor, and remainder. So now that we feel confident in that, we're going to start using long division to divide these polynomials. And this is going to be how we start factoring these polynomials. So for example, you don't need to write this down, but if I were to look for the factors of 24, for example, and I knew that 4 was a factor. So if I knew a factor was 4, what I could do to find other factors is divide it. So if I take 24 and I divide it by 4, I'm going to get 6. And now I have two factors. I have 4 and I have 6. So if we know a factor of a polynomial like this guy here, so if I know this one's a factor, I can find more factors by dividing them. But keep in mind, not every polynomial is going to be a factor of each other. So for example, if I take 24 and I were to divide it by 5, I'm not going to get an even number. I'm going to get a decimal, or which indicates that there was a remainder, which means that 5 is not a factor of 24. So we have to be careful. If we notice that there's a remainder when I start dividing this guy in, I know that x minus 3 is not actually a factor, and it's not going to really help me to factor this thing. So for now, we're just going to practice dividing to check if something is a factor or to find other factors. And then we're going to move on to finding those factors in the next lesson. So let's set up this first question. So we're asked to divide x minus 3 into the polynomial 3x to the power 3 minus 5x squared minus 7x minus 1. So just really quickly, if we were to label these two, this guy would have to be our divisor. So here's what's actually doing the dividing. So this is our divisor, and here is our dividend. So just like 107 and 4, we're going to put those together into a long division sign. So let's start that here. Okay, so starting with our division sign, underneath we have our our dividend, which is 3x to the power of 3 minus 5x squared minus 7x minus 1, and then we have x minus 3 as our divisor. So now we've got to do long division. We're going to follow the same process that we did above. So the first thing we're going to ask ourselves is, how many times does this term go into this term here? Meaning, if I were to divide 3x to the power of 3 by x, what would be left over? So if I took 3x to the power of 3 dividing it by x, I would be left over with 3x squared. So I'm going to put it right on top of the squared term so that these two match up. So if my answer is an x squared, I'm going to put it over the x squared term. So next, let's just multiply this to make sure that this works. So 3x squared and then times x is going to give us 3x to the power of 3. So that's just another check to make sure that I've actually divided these right. But now I've also got to multiply it by the negative 3. So 3x squared times negative 3, that's going to make negative 9x squared. And then we're going to subtract like we did above. So next we have 3x to the power of 3 minus 3x to the power of 3. That's going to make 0, so we don't have anything left over here. Then we have negative 5x squared minus 9x squared. That's going to be positive 4x squared. Then if you look above, our next step was to bring down the next term. And our next term is negative 7x. And we're going to do the process over again. So I'm going to ask myself, how many times does x go into this term right here? Another way to say that is, what's 4x squared divided by x? And we know that that answer is going to be positive 4x. And again, the same degrees are being lined up right on top of each other. So let's multiply this out. Now we have 4x times x. That's going to be 4x squared, which perfectly matches. And then I have 4x times negative 3. That's going to be negative 12x. All right, now let's start subtracting. So we have 4x squared minus 4x squared. That's just going to be 0. And next I have negative 7x minus negative 12x is going to be 5x. And our last step, let's bring this last term down, minus 1, and continue one more time. So how many times does x go into 5x? 5 times. So we're going to put plus 5. Okay, then we're going to multiply. What is 5 times x? And then what's 5 times negative 3? So 5 times x is 5x, and 5 times negative 3 is negative 15. So when we subtract, we're going to be left with positive 14. So if we were to label all of these things, here is our dividend. We know that this guy here, that's our divisor. Up here, that's going to be our quotient. In this case, we do have a remainder. So this is our remainder here, a remainder of 14. So if I were to ask, is x minus 3 a factor of this polynomial here? The answer would be no, because it doesn't evenly divide. We are still left with a remainder. If we had a remainder of 0, then we know that x minus 3 is a factor, and so would this guy. So we can summarize this answer in two ways. So using our summary from above, so let's just zoom out so we can see it. So using this summary above here, we can write this in two different ways. So one way is we can start with the original question, which is what the heck was 3x to the power of 3 minus 5x squared minus 7x minus 1 divided by x minus 3? Well, it gave us the quotient of 3x squared plus 4x plus 5, plus there was a remainder of, so I'm just going to slip it down under here, plus there was a remainder of 14, and we're going to put that over the divisor, which was x minus 3. Another way to write it is our dividend first. So our dividend, which is our, so this is one way to summarize, here's the second way to summarize. Our dividend was 3x to the power of 3 minus 5x squared minus 7x minus 1. That had to equal the product of our quotient and our divisor. So that had to equal 3x squared plus 4x plus 5 times, I should have left a little more space, times our divisor, which is x minus 3, plus our remainder, so plus 14. So two different ways to summarize this. So the next question that we're asked is x minus 3 a factor? And we know that if it was a factor, there would be a remainder of 0 for the same reason that we've already explained with the 24. If I were to take 24 and divide it by 6, I get an even whole number of 4, no remainders. So which means that both 6 and 4 are factors. But if I were to take 24 and divide it by 5, I'm not going to get an even number, which means that 5 is not a factor because we're left with a remainder. So for the same reason, x minus 3 is not a factor because we were left with a remainder of 4. So let's write that out quickly. So in summary, x minus 3 is not a factor of the dividend because it results in a remainder of 14 when we divide it, which is not 0. If it was 0, it would be a factor. So it also asks us to find f at 3. So the question is not really clear, but let's define f at x as the dividend. So that's what we're talking about here. So it's asking us now to find f at 3. So let's just do it. So if f at x is equal to our dividend, and our dividend is 3x to the power of 3 minus 5x squared minus 7x minus 1, let's go ahead and find f at 3. So 3 times 3 to the power of 3 minus 5 times 3 squared minus 7 times 3 minus 1. That's just equal to 14, which is odd because that's the same as the remainder that we found when we divided x minus 3. So what we've happened upon is something called the remainder theorem, which we're going to do in a little bit, which is that if we were to take a linear factor and pull out the 0. So if we were to set it equal to 0, what would x be? And that's 3. And plug in that 3 into our function is going to be the remainder as if we divided x minus 3 into this function. So automatically, instead of actually dividing this thing, if I was just asked, is this thing a factor, I could just plug in the 0, which is 3, into the function, and whatever results will be the remainder, which means that if we get a remainder of 0, we know that it's a factor, and if it's anything but 0, it's not a factor. Now let's try a slightly harder example where instead of dividing in a binomial, we're going to divide in a trinomial. So try it yourself, set it up the same way that we set it up in the previous example, and come back to the video once you get stuck. If you're coming back to the video, that means that you've tried this on your own, but you got stuck. It's really important that you try this on your own. So the reason why we got stuck is there's two things that we didn't take into account. So this guy looks much different than the previous example. Not only are we dividing in a trinomial instead of a binomial, but all of the terms are out of order. What I mean by that is just looking at the divisor, we have the constant term and then the linear term and then the quadratic term, when really we usually write x squared first, then 2x plus 1. So just thinking back to elementary school, if our divisor was 401, we wouldn't write 104. We would write the 4 first because that's the hundreds, and then the tens, and then the ones. So when we're dividing polynomials, we have to do the same thing. We have to write the highest degree first and then write them in descending order. Taking a look at the numerator, we have a power of 4. So we start with x to the power of 4. Then we have a power of 3, and then a power of 1, and then a constant term. Can you see that there's something missing? The x squared, or the quadratic term, is missing. So this brings us to the second thing we need to keep in mind. If we're missing a term, like the x squared term, for example, we need to put a placeholder of 0 in front of the x squared term. So for example, the number 401, there actually isn't any leftover tens, which is why we have a 0 in the tens place. So we have 4 hundreds and then one single, but we put a 0 in the tens place to signify that there are 0 tens. So we are going to do the same thing for the squared term in the numerator. So we're going to write x to the power of 4 minus 2x to the power of 3 plus 0x squared plus 5x plus 3. So the divisor would be, if we rearranged it, x squared plus 2x plus 1. So now that we have everything set up, we're going to start dividing. So even though we're not dividing in a linear term anymore, we've got a linear expression. We've got a degree 2 expression. We're going to do it the same way. First, we're going to ask ourselves, what is x to the power of 4 divided by x squared? Or how many times does x squared go into x to the power of 4, and that solution will be x squared. So we're going to make sure to put it over the x squared part just to keep ourselves organized here. So now we're going to multiply x squared by all of these terms in here. So we have x squared times x squared. That's going to make x to the power of 4. Those two better match up. Then we have x squared times 2x, and that's going to be positive 2x to the power of 3. And then we have x squared times 1, which is going to be plus x squared. So now we can subtract, and we're going to be left over with negative 4x to the power of 3 minus x squared. Next, we're going to bring down our next term, which is going to give us an extra plus 5x, and we're going to do the pattern over again. So now let's ask ourselves, how many times does x squared go into negative 4x to the power of 3? Or what's negative 4x to the power of 3 divided by x squared? That's going to be negative 4x. And maybe we made a mistake, but we can always check that mistake by multiplying it out. We better get that term again. So negative 4x times x squared, that's going to give us negative 4x to the power of 3. And then I've got negative 4x times positive 2x, which is going to give us negative 8x squared. And then I have negative 4x times 1, that's going to make negative 4x. Now that we're ready to subtract, we know that these two terms, when subtracted, we're going to make 0. Then we have negative 1x squared minus negative 8x squared, which is going to be negative 1 plus 8, which is going to be 7x squared. And then I've got 5x minus negative 4x, which is going to be plus 9x. And we're going to bring down our 3. So we have a plus 3. And we're going to repeat the pattern one last time. X squared goes into 7x, positive 7 times. Then we have 7 times x squared is 7x squared, plus 7 times 2x is 14x, and 7 times 1 is plus 7. So we're going to be left over with negative 5x minus 4. So our remainder is actually a linear expression. So here is our remainder. We've already labeled our dividend and divisor, but this guy is our quotient. So now try using the equivalent equations that we came up with on our first page to relate the dividend, divisor, quotient, and remainder together, and try to write it in two different ways and check back in the video, make sure you've got it right. So here are the two ways that we can represent our solution. So the first one, we have our dividend divided by our divisor is going to be our quotient plus a remainder over that divisor. And our second way is we have our dividend. That's going to equal the product of our divisor and our quotient, and then we've got the remainder tacked on at the end. So our final question is, let's just think about it. Is this polynomial a factor of this polynomial? And that answer is no, because again we have a remainder. So we haven't yet found an example where our remainder is 0 yet, which would imply that whatever it is that we're dividing into the polynomial is in fact a factor. So our next question is a little bit different. It's asking us to find the divisor. So we're not given the divisor, but our dividend is this guy here. So that's the thing we're going to divide into. The answer, our quotient, is this guy here, and our remainder is this. So it's like we're given our answer. It's asking, what was the original question? So we can pull from either of the equivalent equations that we had on our first page. Since we don't know what the divisor is, let's pull from our equation where we can first write our dividend. So our dividend is equal to our quotient, which we have, times our divisor, which we need, plus our remainder, which we also have. So let's fill in what we do know. Okay, so here I filled in our dividend because we knew our dividend, our quotient, and our remainder. So now we've got to isolate for our divisor. So first thing, let's bring the remainder over onto the other side. So on this side of the equation, we've got 4x to the power of 5 plus 12x to the power of 3 plus 2x squared plus 8. And then we were going to have a plus 5x when we bring that remainder onto the other side, and then minus 3. And on this side, we're going to still have our quotient, which is 2x to the power of 3 plus x plus 1. And of course, our divisor that we're trying to isolate. Okay, so let's simplify this guy over here. So collecting like terms, we are going to have 4x to the power of 5 plus 12x to the power of 3. And then we have plus 2x squared plus 5x, and then plus 5 is going to equal all of this thing again. Here we go. 2x to the power of 3 plus x plus 1 times our divisor that we are so desperately trying to get on its own. Almost there. All right, let's get this divisor on its own by dividing by this 2x to the power of 3 plus x plus 1. Whatever we do to this side, we got to do to the other side. So we've divided by 2x to the power of 3 plus x plus 1. These two lovely things are going to cross out, which means we're going to be left with the divisor must be equal to this entire thing here. One more time, written it out. We got 4x to the power of 5 plus 12x to the power of 3 plus 2x squared plus 5x plus 5 all over 2x to the power of 3 plus x plus 1. Phew. But we're not done yet, because if this is what the divisor is equal to, we got to figure out what the heck this ugly thing is divided by this ugly thing. So now we know the deal. We're going to do long division. So set it up, have fun, check back in the video to make sure you've done it correctly. All right, so if you finish the marathon of this long division, you would have a quotient that looks like this. Now there was a couple things that were interesting in this problem. So if you didn't get that answer, take a look at a couple things. Did you, one, make sure that you added in a 0 term here in our dividend for x to the power 4, and did you add in a 0 term for x squared in our divisor? If you didn't, there's some mistakes. Also, when you started in our last line here, so when you realize that 5 was our last part of our quotient, and you started multiplying 5 by 2x to the power of 3, that's going to give us 10x to the power of 3, then 5 times 0x squared is going to give us 0x squared, and then 5 times x, which is 5x, but then we still got to do 5 times 1, which is 5. And then we had a blank spot up here. So if you do have a blank spot, just bring down another number. So that's what we did. We brought down another 5 so that when we could subtract it and we would get 0. So if you've forgotten what the original question was asking, that's okay because this was a super long question. So let's go back. This whole process was asking us for this, what was it? We were looking for the divisor. There we go. And we realized the divisor just equal to this. And when we divided it, that is just equal to 2x squared plus 5. And that matches our solution that we were given up there, just to make sure we're on the right track. And that is our final divisor, and we're too tired to write a sentence. Divisor. Ta-da!